now we're going to talk about finding the volume, but not of a solid of revolution. This is a solid with known cross sections. So you're going to have a base, and then we're going to construct something on that base. So you end up with a solid who the cross section at any point is going to be a simple shape that we know how to find the area of. So the formula is just going to be the integral from a to b of a of x, whatever the area formula is. So a of x is the area of the cross section. Okay, so here I've got the volume of a solid whose base is the circle, x squared plus y squared equals 4. And the indicated cross sections. Now typically you'd be told perpendicular to the x-axis or perpendicular to the y-axis, but since this is a circle, it doesn't really matter. Okay, so the first is squares. You can picture this being a square. So this one, if the radius is, or if this is 4, that means my radius is 2. So this is going to be the integral from -2 to 2 of just the area of one of these squares. Well, this distance here, if I solved this for y, this is going to be y equals the square root of 4 minus x squared. So the base of this square is going to be double that. So the base of the square is 2 times the square root of 4 minus x squared, and then the height of the square would be the same thing, so we just have base times height. Then we'll go from here. It's typically, if you have something symmetric like this, instead of going from -2 to 2, I'm just going to go from 2, or double 0 to 2. So if I square this, I'm going to have a 4 here, and 4 minus x squared on the inside. Okay, so I can combine the 4 with the 2 and get 8. And then 4x minus 1/3 x cubed, evaluated from 0 to 2. Okay, so we're going to have 8/3, 8 minus 8/3 times 8. You can just use your calculator to help you there. Is going to be 128 thirds is the volume of that solid. Okay, now what if instead of semicircles we did, or instead of squares we did semicircles? So now my shape, my cross section is going to look something like that. Okay, so we're still going from -2 to 2, which I'm going to change in a second. Of the area of a semicircle is going to be 1/2 pi r squared. So the radius is just going to be that distance here. So it's just going to be the square root of 4 minus x squared squared. So half of a circle, 1/2 pi r squared. So again, I'm going to double the integral from 0 to 2 to make life easier. And I'll deal with that in a second. And then square that, so that's just 4 minus x squared. So if I do 2 times 1/2 pi, that's just going to be pi. And then on the inside, we're going to have 4x minus 1/3 x cubed, evaluated from 0 to 2. So we get 8 minus 8/3 again times pi gives us 16 pi over 3. And again, you can use your calculator to help you with that. For your assignment, just like the last couple, all you have to do is set it up and use your calculator to find it. Okay, isosceles right triangle with a leg on the base. So an isosceles right triangle, we've got two legs that are perpendicular and then the hypotenuse. So that's saying something like that. Okay, well, we're going to have 1/2 base times height. This base, just like with the square, is going to be 2 of 4 minus x, root 4 minus x squared. So this is going to be 1/2 base times height. The base is going to be the square root, 2 times the square root of 4 minus x squared. The height is going to be 2 times the square root of 4 minus x squared. So this is going to be 2 times the 1/2. Changing it from, instead of going from -2 to 2, going from 0 to 2. And then you're going to have 4. The 2 times the 2 gives me that 4. And then on the inside, root 4 minus x squared times root 4 minus x squared is just 4 minus x squared. So 2 times 1/2 goes away. We've got this 4. And then 4x minus 1/3 x cubed. From 0 to 2. Which gives us 64 thirds. Which makes sense that it would be half of the square, since really this would be, this got the square and then that would be half of it. Okay, last is equilateral triangles. And before I do that, I just want to come up with the formula for an equilateral triangle, the area, because that is one that comes up. So if I have an equilateral triangle, all of the sides are the same. So I'm going to say this is the base, and then this is our height. Well, if it's equilateral, that means that's 60, that's 30, which makes this a 30, 60, 90 triangle. If this is the base, this is going to be 1/2 of the base. And if you remember 30, 60, 90 triangles, the long side is root 3 times as big. So my height here is going to be 1/2 of b times root 3, or root 3 over 2. So the area of the circle, or area of the triangle, is going to be 1/2 the base times the height. So if I simplify this, we get root 3 over 4b squared is the area of an equilateral triangle. Okay, so that makes this easy. If I have an equilateral triangle, the base is going to be that 2 root 4 minus x squared again. So this is going to be the integral from -2 to 2 of root 3 over 2 so we're going to have, if I do 2 times root 3 over 2 times the integral from 0 to 2 of 4 okay, and we get the same math again. So root 3 So we're going to have 4 root 3 times that 4 times 2 minus 1/3 2 cubed, which gives us 32 root 3 over 3. Okay, so we're going to find the volume of the solid whose base is bounded by the graphs of y equals x plus 1, y equals x squared minus 1, with the indicated cross sections taken perpendicular to the x-axis. So we have the line y equals x plus 1, so up 1, that. And then we have the parabola x squared minus 1, so it's going to go down 1, it's going to go over 1, up 1, over 1, up 1, over 2, up 4. Okay, so this point here is 2, 4, this point here is negative 1, 0. So this is going to be my base for all of these. And then it's just the integral of the area. So if we have a square, this is going to be the integral from negative 1 to 2 of the top minus the bottom. That's going to be our distance squared. So the top is going to be the x plus 1. Minus the bottom, which is x squared minus 1. Okay, now you can simplify this, and we can certainly easily do this. I'm just going to go ahead and, so that's the base, and then we want the area. So it's going to be that base squared, which if you type it in the calculator gives us 8.1. Okay, if we do the same thing with rectangles of height 1, we're going to have the integral from negative 1 to 2 again of base times height. So the base is just going to be that x plus 1 minus x squared minus 1 again, times the height of the rectangle, which is just going to be 1. Okay, when you type that in the calculator, we get 4.5. Okay, semicircles. So we're going to have 1/2 pi r squared. The radius is going to be half of that distance that we used for the square and the rectangle. So it's going to be 1/2 of x plus 1 minus x squared minus 1. So pi r squared. Number of parentheses, I think we're good there, which gives us 3.181. And then equilateral triangles is going to be root 3 over 4 times the base squared, which is just going to again be that x plus 1 minus x squared minus 1. Which gives us 3.507. So these known cross sections are pretty easy. The biggest thing is things like this, like the radius is going to be half of that full distance, or on the other ones, like doubling it. Okay, find the volume of the solid whose base is bounded by the graphs of y equals x cubed, y equals 0, x equals 1, with the indicated cross sections taken perpendicular to the y-axis. So we have y equals x cubed, which is going to look like that in the first quadrant. Okay, and it says y equals 0 and x equals 1. So this is our base. And we're constructing things perpendicular to the y-axis. So my shapes are going to be, the bases are going to be like this. Okay, so if it's squares, got our square here, I need to find this distance here. Well, if this is y equals x cubed, that means x is equal to the cubic root of y, or y to the 1/3. So this distance is x, which is y to the 1/3. So the base is actually going to be 1 minus that. So this one's going to be the integral from 0 to 1 of 1 minus y to the 1/3 squared, since we have a square. Okay, so we get 0.100 when you do that. And then similarly with semicircles. So we're going to have the integral from 0 to 1, because we're going up from here to here, of 1/2 pi r squared. So 1/2 pi, the radius is going to be half of that. Anyway, type that in the calculator, 0.039. Okay, and then our last problem here, we're going to find the base of a solid is bound by the line x plus y equals 4 and the coordinate axis. What should the volume of the solid if cross sections perpendicular to the x-axis are a semicircle? So y equals, or x plus y equals 4. It's just going to be a line like so. Our cross sections are going to be perpendicular to the x-axis. So this is going to be y equals 4 minus x, or you can do negative x plus 4 if you want to. This is going to be the integral from 0 to 4 of 1/2 pi r squared. 1/2 pi. If from here to here is 4 minus x, then my radius is going to be 1/2 of that. And then we're just going to simplify this down to get something that we want. So I'm going to pull out the 1/2 pi. I'm going to distribute through the 1/2. So we're going to have 2 minus 1/2 x. We're going to square that. So we're going to have to FOIL. So this is going to be 4. If I multiply 2 times negative 1/2 is just 1, and then we're going to have 2 of those. So minus 2x plus 1/4 x squared. So we're going to have 4x minus x squared plus 1/12 x cubed. Okay, and if you plug all this in with the 4, so we're going to have 16 minus 16, so those are going to go away, plus 1/12 of 4 cubed is 64, and then multiply that times the 1/2 gets us, so I just have it as 8 pi over 3, which is C. So known cross sections aren't too difficult, but just thinking about the shape and what you need to find its area.